Hello everyone. So today we will be talking about applications of lasers in material science and engineering and related fields. We will also try to talk about the application of lasers in optical communications. So the laser is applied in various areas of material science and engineering in metallurgy. And these are very much important for industries. Okay, so there are several areas that has come up over the years after since the inception of this laser, like laser welding, laser cutting, laser cladding, laser pinning, laser surface engineering, surface chemistry, purification of materials, and laser induced polymerization, to name a few of them. So let us start by talking about laser welding. So laser beam welding is a technique in manufacturing whereby two or more pieces of material, usually their metals, are joined together by the use of a laser beam. Okay. So conventionally what is done, when you want to join two metals, then you come with a very high temperature flame, and then you join them together. Okay, that is known as conventional welding. Here, instead of that high temperature flame, you use laser beam. So the weld is formed as the intense laser light rapidly hits the material, and this happens in short time scale over a millisecond time period. The main types of laser that are used in this welding process and also in cutting are essentially the gas lasers, which can give you really high power, for example carbon dioxide laser, also solid state lasers like Nd:YAG, and modern day diode lasers are also used for these purposes. These lasers are used for materials that are difficult to weld using other methods, because sometimes they may be hard to and also access certain areas for the conventional welding instrument. Also in those cases where you need to weld a very tiny object, so in the size of say millimeter or micrometer kind of object dimensions, there also you cannot use a conventional welding machine, and you have to use a laser technique to weld them. Okay. So these are the advantages of laser based welding techniques. Okay. So one, if you have a material which is really hard to weld. Second, if you do not have access to the region, there you can or you have to use laser based welding. And also for tiny components, say for example like in a some cheap or that kind of stuff, you have to use laser based welding. And in laser welding, the absorption of energy by a material is affected by many factors, such as the type of laser, the incident power density, and the surface condition of the base metal. Okay. Depending on that, one can achieve the efficiency of the welding by using laser. Now as we know that laser output is optical, not electrical, right? And so we don't need to have an electric current flow into this metallic system which we need to weld, and this eliminates the any possible effect of magnetism, and also we in this way we do not limit the welding process to only electrically conducting materials, which is the case in many conventional welding techniques. and these lasers can interact with any material, and it does not require a condition like vacuum, or it does not create some adverse rays also. Laser output is not this is just repeated by mistake. The laser beam has been used to weld carbon steels, high strength low alloy steels, aluminum, stainless steel, titanium, and various other materials. Now, though they have a lot of advantages, certain disadvantages are there or limitations are there. What are they? That is, rapid cooling rate may cause cracking in some material, because you are using laser for a short period of time. So, you just create that heat in a very short moment, and then you withdraw your laser, right, the light is off. So, there is no source of heat anymore, and then this rapid heating, and then there will be rapid cooling, and this can create a problem by like generating cracks in the material. Second thing is that conventional, compared to conventional welding machine, lasers can be expensive. So, the cost wise it is a little bit problem. Optical surfaces of the lasers are easily damaged. So, when you use this laser to weld something, so from there you many times get a lot of vapors and all those stuff, and that can get accumulated in the optical surface of this laser, and over the time this optical surface goes bad, and it happens quite often, and once the optical surface go bad, the laser performance in welding also deteriorates. And lastly, that if you are using a laser system for your welding purposes, then you need to bear the maintenance cost for this laser system as well. So, these are some limitation, not necessarily that these are big limitations. So, for example, like if you have enough capital to buy and maintain these systems, they are of no problem. Certain figures showing this welding and cutting process. So, here like two parts are being joined together, weld together by using the laser. Same is done on the right side image. Okay, and this is a schematic of the process where the laser beam is focused using a lens, and this is passed through a nozzle, where through also you send in some gas under high pressure, so that you can create the exact environment on the metal surface which you are trying to weld is created. Okay. Next, we will be talking about another process called laser cutting. So, laser cutting works by directing the output of a laser, essentially a very high powered laser, through optics. So, the arrangement is pretty similar. You bring your laser, focus it really hard onto the surface that you want to cut. So, this laser optics and the computer numerical control are used to direct the material or the laser beam generated. So, you can either move the material that you are going to cut, or you can move the laser head. So, either is fine, and you can do that in a computer controlled manner. Okay. And not only the laser, but the associated optics also can be moved. This focused laser beam is now directed to the material which then either melts or burns or vaporizes, or simply you blow away by a jet of gas, like I showed in the just previous slide for welding, which leaves an edge with a high quality surface finish. Okay. So, this is a very big advantage of laser cutting compared to a metallic cutting, where you have a rough surface edge. Laser will give you a very nice finish of the surface edge. Industrial laser cutters are used to cut flat sheet material as well as structural and piping material. So, you can do any sort of cutting pretty much using laser, and that's why this is a very industry is a pretty big fan of this laser cutting. Uh, you know, you can also pierce through material, and this piercing usually involves a very high power laser pulses which makes a hole in the material, and making this hole takes like anything between 1 to 15 seconds. If you have like a half-inch thick stainless steel, which is amazing, right? I mean, this is really a very short time if you think about it. So here are some examples shown for this laser cutting and laser drilling. So here you can see that replica structures are being made, and this whole laser arm is computer controlled, and you essentially what you do, you draw the structure that you want to make by cutting say a sheet of metal, and then essentially you program the motion of the laser head along with its optics, and then you turn it on, and then the laser follows that program, and then it cuts the metal, and it just replicates everything ditto, and you can see that in all these pictures. Okay, and here this is this image it shows the laser cutting along with the cleaning of the debris that are formed during cutting, because it can ablate, it can vaporize, it can do several things. So high flow of some inert gas at that region will blow things away, so that you get a clean surface at the end. Now, what are the lasers that are used for this laser cutting purposes? There are basically 3 different types of laser: carbon dioxide laser, neodymium laser, or neodymium YAG laser, that are used for either cutting or boring or engraving. Okay. Now, what are the advantages of the laser cutting over machine cutting? Some of them we have already discussed. Let us have a look at them again. So, it's it's easier to handle. You have less contamination in the on the piece of metal that you are working on. The precision is way better, because the laser beam does not wear during the process, unlike the machines. So like if you have a saw which you used to cut a metal sheet, so during this process the saw is also getting damaged over the time, and this is called wearing process. But a laser light doesn't have this drawback, so it doesn't get wear, and that is the reason you have much precise cutting. There is also a reduced chance of warping the material that is being cut, as the laser system have a small heat affected zone, because you are focusing to a very tiny spot. So in the range of micron, compared to conventional machine, this is really small. So there is very small region where the heat is created. So this is restricted to a very narrow region, and that is why the warping of material is the chance of having it having a warping is limited. Some materials are also very difficult or impossible to cut, just like we said in case of welding, and for those materials we can use laser cutting over the traditional say saw cutting. One additional thing I would like to mention here is that the laser cutting for metals has the advantage over plasma cutting of because it can be more precise and using less energy when cutting sheet of metal. However, most industrial lasers cannot cut through the greater metal thickness than plasma can. So if one is interested of cutting really thick metal sheets, then one may need to use a plasma cutting option, but other than that everywhere laser cutting is superior compared to either plasma cutting or of course the conventional cutting techniques. Next we will talk about laser cladding. So, the laser cladding or laser deposition is a processing technique that is used for adding one material to the surface of another in a controlled manner, and for this a stream of desired powder is fed into a focused laser beam as it is scanned across the target surface, leaving behind a deposited coating of the chosen material. Okay. So, what it does essentially, this enables the applied material to be deposited onto the substrate surface, and not only that, you can deposit that in a very selective manner, that wherever you want you can deposit it. Okay. Additionally, you can again come with another material and deposit on the top of the first one. Okay. So, you can have a very wide choice of different materials that can be deposited or deposited onto the previously deposited material. The deposits are fully fused to the substrate with little or no porosity, which is a big advantage. The minimal heat input results in narrow heat affected zone, which we already discussed in the case of laser cutting. And this because of this narrow region of the focal spot, and which in turn creates the minimal heat input, that results in limited distortion of the substrate and reduces the need of additional corrective machining. Okay. Certainly a big advantage. Now, you can automate this process altogether using CAD or CAM and computer controlled production environment. So, here this schematically it is shown how this cladding is done. So, you have a supplier of powder in terms of in the form of a spray, which goes to the surface, and there it meets the laser beam and gets deposited there. Okay. So, you can program where these guys will be getting deposited exactly. Next we will talk about laser pinning. Laser pinning or laser shock pinning is a surface engineering process used to impart beneficial residual stresses in material. In certain cases you need some residual stresses within the material, and using laser pinning you can actually do that. The deep high magnitude compressive residual stresses induced by laser pinning increase the resistance of material to surface related failures such as fatigue, fretting fatigue and stress corrosion cracking. So, this is more like having impurity in a crystal can be better in for certain systems. Here also, like having some additional stress can be beneficial, as we said just a minute back. So, what are the plus points? So, this laser pinning, it enables the applied material to be deposited selectively, note this, just where it is required, pretty similar to the cladding that we discussed. Fundamentally, laser pinning can be accomplished with only two components, a transparent overlay and a high energy pulse laser system. Very wide choice of material you can have, like laser cladding. The transparent overlay confines the plasma formed at the target surface by the laser beam, and it also often beneficial to use a thin overlay opaque to the laser beam between the water overlay and the target surface. Now, this opaque overlay can provide either one or each of the following benefits. For example, It can protect the target surface from potentially detrimental thermal effects, which is obviously you can expect from laser beam. Second, it can provide a consistent surface for the laser beam material interaction. And third, if the overlay impedance is less than that of the target surface, increase in the magnitude of shock wave entering the target. Now, laser pulses are generally applied sequentially on the target to treat areas larger than the laser spot size. It has to be, and the laser beam shapes are customizable to any shape like circular or elliptical or any other thing like square, to provide the most convenient efficient processing condition. So, here we show schematically how this pinning is done. So, the laser pulse, it creates the plasma at the surface of this, which is opaque overlay, and also it creates the shock wave on the other side. Next, we will talk about the laser surface engineering as the last topic in this section. So, many of the most important topics in this field concern the treatment of semiconductor surfaces, and therein hold enormous potential for application in the manufacture of microelectronic devices. Many of us already know that the semiconductor industry has kind of revolutionized the microelectronic device industry, and what we are going to talk about, actually it is of concern in those fields. So, it is worth noting that excimer lasers in particular produce emission in a very useful wavelength, where photon energies are sufficient to break chemical bonds. We have seen that in earlier case of biomedical application of laser. So, this excimer laser fundamental frequencies or their harmonics, they can break the chemical bonds in different compounds, and for us the important compounds are those which involved group 4 elements. For example, the dissociation of propan-2-ol over copper oxide using 1070.5 centimeter inverse radiation from a carbon dioxide laser, there are two competing reaction pathways leading to different products. So, one is propanone, another is propene. So, the product ratio of this propanone to propene can be varied from 0.02 to 0.26 depending on the orientation of the catalytic surface with respect to the laser beam. Many laser induced surface engineering involves the principle of depositing a thin film covering onto a substrate surface by decomposition of a gas, and this process is very well known as laser chemical vapor deposition. The mask free writing of an adsorbate onto semiconductor surfaces by laser deposition provides a classic illustration of an application facilitated by distinctive properties of laser light. And the principle involved in the process of deposition in this manner can be either pyrolytic or photolytic by nature. Now, both the types, either pyrolytic or photolytic of this deposition, the laser irradiance is typically in the range of 10 power 12 watt per centimeter square, and the vapor pressure of the gas is required to be between an atmosphere to 1 millibar. Okay. And at this condition, the rate of the deposition with a scanning laser system are typically between 0.1 to 100 micrometer per second. Now, individually, if we look at pyrolytic and photolytic decomposition, the pyrolytic decomposition involves thermal reaction and is in general an indirect result of the surface heating produced by the laser radiation. For example, amorphous films of silicon can be pyrolytically deposited onto a silicon hydride vapor, from a silicon hydride vapor onto quartz or various other surfaces irradiated at particular wavelength of 10.59 micrometer from a carbon dioxide laser. On the other hand, photocatalytic deposition, photolytic deposition result directly from the absorption of laser light by the molecules of the vapor. Okay. So, here we provide another example where this example is materialized by using 193 nanometer laser light from excimer laser. Also, we can use this laser radiation for purification of material, and here the underlying principle is the specific excitation of a single chemical component in a mixture. In this case, usually the impurity. So, we have talked about this very many times. We have talked about this one when we discussed about the chemical application and also in separation techniques like isotope separation. So, here also it uses the same principle, that monochromaticity of laser light that can be used to excite selectively one particular component, and then you get rid of that by some other means. So, essentially you can get rid of the impurities. So, one more thing I will discuss here is the preparation of polymers, or in other words the polymerization initiated by lasers. So, normally the pulsed UV radiation that is employed to produce radicals for the process initiation, generally it's generally proves that there are substantial differences in the character of polymers obtained with laser radiation compared to that produced with the radiation of from conventional light sources. One reason for this is that the high intensities associated with laser radiation can be increasing the transient concentration of radical intermediates and substantially increase the extent to which the sequential absorption processes enter into the reaction. Second reason can be that it is more directly connected to the pulse nature of the radiation, and the length of the, particularly the mean length of these polymers that are produced by this laser excitation are essentially proportional to the dead time or the dark time, that is the time between two successive pulses. Okay. So, the product is characterized by the molecular weight distribution more directly amenable to control and generally quite different from the polymer produced using conventional photo initiation. So, in a pulsed laser system, since the dead time dictates the polymer chain length, so you can actually control the molecular weight of this polymer produced by lasers in a much better way than what you obtained in case of normal or conventional source initiated polymerization. So, with this we will stop this particular section, and we will move on to the other applications of lasers, particularly in the field of laser communications. So, the laser communication systems are normally wireless systems. So, any communication system we think of, they are connected via some sort of connectors. So, where fiber optic cable and etc., but laser communication, it is like a direct communication without the need of any wired system. So, it is a wireless connection, and here the laser beam is used to transmit information between two locations. So, at the source and then the region where the signal is received. So, as I said, there is no fiber required because it is a wireless technology, and you can really achieve communication between a very large distances. Okay. And how long that distance can be? To give you an example, it can be a communication between two planets. Okay. Now, say for example, we can have a communication from Earth to Mars. This laser communication terminals transmit a laser beam and are capable of receiving laser beam. Okay. So, between these terminals we can have the talk or communication. Now, how does it work? So, here schematically we so you have uh, you know some signal we are giving to the laser through a transmitter, and then this laser, it sends to the laser beam, goes to the receiver on the other hand, and which again generates a signal. So, between the two source we can have the communication. Okay. So, one signal is sent to another place via this laser communication. So, this is exactly how it is done, is shown here. So, this is a one-way communication system where you are using a receiver like a which can detect light like a photodiode. So, you take the laser light and you you collimate the beam, and then again second lens system, which is essentially a telescopic system. We already talked about this one, like if you want to collect signal from far distance, you have to use a telescopic system. So, here you use a transmitter lens at the beginning, and then you have to use a telescopic lens system to collect that signal and then detect it. So, that will act as a receiver. All right. Now, first is the transmitter. So, transmitter is, of course, you have to have a laser. So, mostly laser diodes are used for this purpose. On the other hand, you have to receive on the other end, and the receiver can be some detector like it can be like an antenna, like a telescope system, having a detector like PIN diode or avalanche photodiode, or PMT based detector or CCD based detector. They all can act as a receiver of this signal. Now, in this communication system, we do not need any fiber. So, in which way this is better than fiber optic communication, and why don't you use fiber optics in the laser communication system? See, the problem is that it is not possible to put the fiber optic cable everywhere. Okay. So, like if you are talking about communication between two planets, it is not possible to lay the fiber optic cable, right? And also, if you want to have a communication where war is going on, I mean you place the fiber optic cable, and it goes in no time. Okay. And if you want to lay this fiber optic cables, it can be really expensive, and suppose you need to have a communication on emergency basis, then you should have a mean to do that, and that is where the laser communication come into the play. Okay. So, essentially because the fiber optic cable connectivity may not be possible in certain cases, it may be expensive, it so wherever it is not possible to do that, and wherever you can avoid having fiber optic cable network, you can use laser communication network system. And if I again ask, then okay, fine, I understood about the fiber optic network, why not? Then why not radio frequency? So, here the problem is the bandwidth. For laser communication, the bandwidth is 100 times greater than that for radio frequency. In terms of power, in laser communication system, is the laser communication is directed at target. So, so much less transmission power is required. Moreover, because it is a direct communication, the loss is also very less. Third, the LC antenna which receives is much smaller than radio frequency antenna. And fourthly, due to low divergence of laser beam, laser communication is more secure than RF. So, many cases if you want to transmit data which you want to keep really secured, you would need a system which doesn't diverge much, so that others cannot intercept that one. So in that regard, laser communication is far better option compared to RF communication system. All right. So what are the different sectors where this laser communication is applied? It is applied in the ISP sector, which is the internet service provider. So there is a huge connectivity between several internet provider radar system. So it can be also in the mobile systems, mobile networks also. In industry, you have the communication between several components, several equipments, okay, and they are all tethered together one main computer that controls all these communications. You can also have applications of this laser communication in defense or other sensitive areas, at airports. So for communication across the runways where you would not like to have any kind of interruption, for mass communication, and of course for free space communication, like between planets. And the space probes are being designed to use optical rather than radio communications, and the laser communication has also been demonstrated on aircraft and high altitude platform, okay. And not only that, you also have a laser communication system being implemented for underwater communication. So as shown by this picture, like through satellites, terminals, the communication is done region even below sea to the submarines. So what are the security aspects? Free space laser communication systems have narrow optical beam which are not accessible unless viewing directly onto the transmission path, as I was saying. So less divergence, so very less chance of interception of that particular information that is being passed. So any potential eavesdropping will result in interruption of the data in transmission. So if there is anyone tries to see this signal, it has to be just come to the beam path, and in that case your communication will be immediately gone. You will realize that okay, something is problem. The existence of laser beams cannot be detected with spectrum analyzer, which is a very advantage, because it will not go and scatter like RF. So what are the advantages? It is easy to deploy. You don't need a fiber optic cable or big receivers, etc., etc. It can be used to power devices, and you don't have a problem of licensing. So license free long range operation, which is not possible in case of radio communication. You can have high bit rates, low bit error rates. They are immune to electromagnetic interferences, which the other kind of communication techniques are very often suffer. They suffer from this electromagnetic interference. Whenever some problems or like solar storm happens, this communication system just goes haywire, which is not the case in case of laser communication. You can duplex the operation fully, and you can have many other things like you don't need any Fresnel zone. No technique is free of disadvantages. So is our laser communication process also. So for terrestrial applications, the principal limiting factors are like beam dispersion, atmospheric absorption, rain, fog, snow, scintillation, interference from background light sources like sunlight, shadowing, pointing stability, also pollution, smog. All of them would lead to loss of the laser light, and hence the communication will be disturbed. So, but given these disadvantages, the advantages seems to be much higher much better for laser communication over any other communication system. So, today what we have seen is that lasers have applications in various different sectors of medical sciences, and also just now we have seen that in optical communications laser is being used, and those optical communication driven by lasers are being used in various different sector of our life. So, the next class will be the last class that we will be having in this course, and I will be talking about one very important aspect which is laser safety. So, I will see you in the next class. Thank you very much.